Hey everyone, as promised, this is how to solve problem 14 in the chapter 4 homework for my Econ 1B students. This is another one of our consumer choice problems, right? Looking at utility curves and how to find out how much people want the optimal bundles and demand curves and constrained consumer choice. So this problem's weird because it's a Cobb-Douglas utility function. If you don't remember or you haven't heard before, Cobb-Douglas functions are functions where the exponents of the inputs add up to 1. So this Cobb-Douglas utility function says that the utility is equal to 100 times x to the 0.75, y to the 0.25. And that's what makes it Cobb-Douglas, is the two exponents add up to 1. And you can see Cobb-Douglas production functions too. And so they're weird because they're exponential, but there are also some cool tricks for solving Cobb-Douglas problems. So if you go in and ask for help with this problem, it's going to direct you to a solved problem that says, well, if you have some utility function, like the utility associated with burritos and pizza, that you can solve it with some constant times burritos to the alpha and pizza to the beta. You can solve for a couple of different things using that, right? You can solve for the demand as a function of the price of the two goods and the income. So it's going to be that B is equal to income y times the exponent divided by the price of B and those two exponents added together. But what that really is, if you break it down, if it's a Cobb-Douglas and these two add together, remember I said a Cobb-Douglas, alpha plus beta equals 1. Like here, what you really get is this simplifies down to that exponent times the ratio of income to the price of the good. That's a lot simpler, right? Because this is going to be 1, so 1 times PB is PB, and then this is just now y times alpha divided by PB, and so you can simplify it this way, and that makes it a lot easier to solve this problem. So let's look at it. So what that means is, and you can actually see this in one of the problems we went over in class today in chapter 5. But what we want to do then is we want to take the income this individual has. So let's go ahead and add that info in here. Their income is $800. And then we need the price of X and the price of Y. The price of X is $12. The price of Y is, that makes sense. Y wouldn't work because we're already using Y. So let's call it X and Z. The price of X is 12. The price of Z, 2, is 10. So that means that we can solve for the demand of X as 0.75 times 800 divided by the price of X. So 800 divided by 12 times 0.75 gives you the demand for X for this individual is 50. For Y, it's going to be 0.25 times income divided by the, I keep doing that. It's not Y, it's Z. Times the price of Z, 10. So 800 divided by 10 is 80 times 0.25 gives us 20. So that's one of the cool tricks with a Cobb-Douglas utility function. It looks a little bit harder than it is. Hopefully that helps, and then that'll help you just speed through that problem. For a reference point, like I said, there is a solved problem in the book that uses this function or this format with burritos and exponents. You can only do this if it's a Cobb-Douglas and these two add together. Otherwise, you have to use that longer form of the value or the quantity of B is equal to income times alpha, and then divided by the price of B and the two other exponents. But if those two other exponents are 1, then that simplifies out a lot and makes your life a lot easier. So, sound good? Hopefully. Let me know, and I will put together a participation activity to help you practice the skills from Chapter 5 next, and we'll keep hustling on this consumer choice stuff until next time. Have a great rest of the day, and I'll see you next time.